Okay, so today we're going over simplifying radicals, and we're going to simplify radical expressions, including those with variables. So last week we talked about expressions that have a exponent that is greater than 1. And then this week we're talking about all kinds of exponents, and we're throwing in a square root symbol. That is what the radical means. So let's write that down real quick. Square root symbol equals radical. That is what that is called, or roots. Also, you need your calculator open so that we can write down some perfect squares, because that is important. Perfect squares. Your notebook, yes. Okay, this is where we need to look at our perfect squares. Their roots can be positive or negative. We did the first 25 perfect squares. We squared 1, 2, 3, all the way to 25, and then we determined or discussed that 169, the square root of that, can be positive 13, which is my positive root, or negative 13, which is my negative root. Most times in Algebra 1, we will deal with the positive root, okay? The negative root does exist, and he'll come into play in Algebra 2. Radicals or roots are the inverse operation of applying exponents. I am undoing a square, a cube, a raised to the 4th power, a raised to the 5th power. I'm undoing it. So first I start off by squaring, which is 3 times 3. I'm multiplying a number by itself, and that gives me 9. Then if I undo that, that means the square root of 9, I'm going to get 3. Okay, that's just taking it and going backwards. So if I say 7 squared, what is 7 squared? We just wrote it down. How much? 49. So then the square root of 49 would be 7. Okay, easy peasy lemon squeezy. Now we've got to determine these vocabulary words. What is a perfect square? A perfect square is a product of a number or an integer times itself. Whoops, LF. Okay, I'm taking any integer and I'm multiplying it by itself. The integer is 12. 12 times 12 is 144. 144 is the perfect square. 12 is the root. 49 is the perfect square. 7 is the root. 9 is the perfect square. 3 is the root. Okay? A prime number is a number with 2 factors. And what are those 2 factors? 1 and itself. Meaning I can't divide it by anything other than 1 and that number. Who can give me an example of a prime number?
I know 1.
What's a prime number?
1.
Ooh, close. 1 is a special case. It's called a unit. Wait a minute.
Bro.
1 is a special case because it only has 1 factor. Thank you for bringing that up, actually.
That's why I did it. I knew what we were going.
Right, because that's exactly where we were going to go. Now, and there's only one even prime number, which would be who? 2. Okay? 2 is prime, but it's the only even prime number. So, thank you for looking up the list. 2 is prime. Who else? 3 is prime.
11.
5. 11.
13.
Is 9 prime? No, because I have 3 and 3 as factors of 9. This says I can only have 1 and itself. 13. Who else?
19.
7. 23. 19. We can go on and on all day. Okay, 29. Absolutely. So, when all else fails, if you don't know if it's prime, jump into Desmos and just start dividing. Can I divide 54 by 5, by 6, by 3? I always start with 2. Is it even or odd? If it's even and it's greater than 2, it is a composite number. That's the opposite of prime. It's got more than 2 factors. Okay? So, now let's jump into simplifying these radicals. I've got 80 here. 80 was not in my perfect square list. Anybody see 80 over here? We saw 81, but we didn't see 80, right? So now I have to take 80 and break it into its perfect square factors so that I can take out my perfect square factor and simplify that radical. You're going to need this for geometry next year when y'all are dealing with triangles. Let's make a T-chart of factors. Y'all remember these from elementary school? We're going to write down factor pairs of 80 and then determine who's a perfect square. So, for starters, what times what gives me 80, starting with 1? 1 times 80. Now, here we have located our factor pairs that give us 80. 1 times 80, 2 times 40, 4 times 20, 5 times 16, and 8 times 10. Now, which of these numbers on the left side or the right side is over here in my perfect square? Did I have 1? Did I have 4? 9, 16, 25. Who's over there? 4 is, and who else? 2 isn't a perfect square. 4 and who? 16. 1 is, we can't factor out 1, because if we factor out 1, we can't simplify it from there. So, 1, 4, and who else? 16. I want the greatest one, which is 16. Okay? That way it makes my factoring easier. So now we're going to rewrite our radical. And now I need 80. What times what gives me 80? 5 times 16. Okay? Once I separate them under the radical, I am now going to give them their own radicals. The square root of 5 times the square root of 16. Good morning, sweetheart. Welcome back. Then, do I have 5 as a perfect square over here on my list? No, he has to stay under the radical. But I have 16, right? What is the square root of 16? 4. So I can simplify this and say that this is 4 times the square root of 5. And typically, I write it the other way around, where I put the 4 in front and then the radical next to it. This is read as 4 times the square root of 5, which equals the square root of 80. They're the same. This one is just simplified. Now, most times when you see this on a test, it's going to be multiple choice. You could put the square root of 80 in the Desmos, and then you can put all of the multiple choices in the Desmos and find out which one is equal. That's the cheat code. You're welcome. Looking at this next one, I've got to find my factor pairs of 54. Who goes into 54? Okay, we found our factor pairs, 1 and 54, 2 and 27. At 27, we identified other factors that go into 27. If it can go into 27, it can also go into 54. So we wrote down the 3 and the 9. After that, we wrote 3 and 18, and 6 times 9, I covered the 3 and the 9. Then I found my what factor? What was this called? The perfect square factor. Now I'm going to write 54 as 9 times 6. Remember, multiplication is commutative. I don't have to put the 6 first. I should have put the 16 first, but oh well. Then I'm going to separate the radicals. Square root of 9 times the square root of 6. What is the square root of 9? It's up at the top. So this becomes 3 times the square root of 6, and this is my final answer. Okay, my perfect squares are the square root of 9, x squared, y squared, y squared again, and z squared. The non-perfect squares stay under the radical. So let's make another radical for the non-perfect squares. That is 10 and an x. And no y's. Good, you're paying attention. And a z. Because this one's gone, 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 and this one's gone. My perfect squares are gone. I'm left with 10 times x times z. Now I can square root these guys. What is the square root of 9? It's at the top of the paper. 3. Trick question. What is the square root of x squared? I'm cutting this square in half and I'm left with what?
X.
I'm left with x. I'm cutting this square in half and I'm left with what? And another y. I've got to put those together. So technically, I should have left it as y to the 4th power and then cut the 4 in half, but whatever. Now I have 2 y's because I had to cut 2 of them in half, and then z. Then I multiply all of that by what is still under the radical, which becomes 10xz times all of this. Did I lose anybody? Did I break it down? Okay. Okay, I've got the square root of 16, the square root of r squared, the square root of k to the 4th, and t to the 4th. Who stays under the radical? 2 and t. So the square root of 2t, and then the square root of 16, r squared, k squared, t squared. I ran out of room. Now let's cut the squares in half. And then what is the square root of 16? No. What times itself gives me 16? 8 times 8 is 64. Go back. What was the square root of 16? 4. 4, R, because we're cutting that in half. K, we're cutting that in half. And T, we're cutting that in half. And then we leave 2T under the radical. Okay, the IXL lesson that goes with this is ZFF. That will be due toward the end of this week. You need a SMART score of 80 per usual.